First, open your terminal. To perform the necessary actions, you need root access. Enter the command sudo su. This command grants you superuser privileges, allowing you to execute commands with administrative rights. Next, let's check the current mode of your wireless interface. Run the following command, iwconfig. This command displays your wireless interface settings. You'll see that your wireless interface, usually named WLAN0, is currently in managed mode. Before switching modes, you need to bring down the wireless interface. Execute the command ifconfig WLAN0 down. This command temporarily disables your wireless interface, preparing it for mode change. To ensure a smooth transition, you must kill any processes that might interfere with the mode switch. Run the command erman ng check kill. This command terminates any conflicting processes that could cause issues while setting the monitor mode. Now let's switch the wireless interface to monitor mode. Execute the command iwconfig WLAN0 mode monitor. This command changes the mode of your wireless interface from managed to monitor. In monitor mode, your wireless interface can capture all packets in the network, not just those addressed to it. After switching modes, you need to bring the wireless interface back up. Run the command ifconfig WLAN0 up. This command re-enables your wireless interface, now operating in monitor mode. Finally, let's verify that the mode change was successful. Run the command again, iwconfig. You should see that your wireless interface, WLAN0, is now in monitor mode. Congratulations! You've successfully switched your wireless interface to monitor mode. Open your terminal and enter the following command, aerodump ng WLAN0. This command will display a list of all the wireless networks within range, along with their respective details such as BSS ID, channel, and encryption type. Identify your target network from this list. In our example, the target network is TechSky. Now, we'll focus on capturing the handshake packets from the target network. To do this, run the following command, aerodump ng BSSID. Write the MAC address of the target network. Channel, write the channel number here. Write WPA_handshake, which is the name of our captured packets file. WLAN0, which is the name of our wireless interface. Once you run this command, aerodump ng will start capturing packets from the target network, displaying both the network details and any connected clients. To capture the handshake, we have two options. Passive capture. Simply wait for a device to connect to the network. When a device connects, the handshake packets will be transmitted, and aerodump ng will capture them. Active capture via deauthentication attack. Force a connected device to disconnect and reconnect, thereby triggering the handshake. This method is faster and more reliable. Let's explore this method in detail. To perform a deauthentication attack, we'll use AirPlay-NG. This attack will momentarily disconnect a device from the network, causing it to reconnect and generate the handshake packets. Run the following command, AirPlay-NG deauth4 indicates 4 deauthentication packets. A specifies the MAC address of the target AP. C specifies the MAC address of the client device to be disconnected. WLAN0 is the wireless interface in monitor mode. To find the client MAC address, look at the list of connected devices in the aerodump ng output. After running the deauthentication command, the target device will disconnect and then reconnect to the network. During this reconnection, the handshake packets will be transmitted. check your erodump-ng terminal to see if the handshake was captured. You should see a message indicating the capture of the WPA handshake. Once the handshake is captured, you'll see a line in the erodump-ng output indicating a successful capture, typically shown as WPA handshake BSSID of the target access point. Congratulations! You've successfully captured the WPA handshake. For this demonstration, we will create a word list that consists of passwords made up of only 2 characters, 1 and 2. The passwords will be 8 characters in length. Now, open your terminal and run the following command. Crunch, it is the name of the tool. 8 specifies the minimum number of characters for the password to be generated. And next 8 specifies the maximum number of characters for the password to be generated. In our case, we are only interested in generating passwords of length 8. That's why the minimum and maximum lengths of passwords are the same. 1, 2. Specify the characters that we want to use in the password. wordlist.txt. Option specifies the file name where the passwords are going to be stored. After running the command, Crunch will generate the word list and display its progress in the terminal. The output will indicate the total number of generated passwords, the size of the word list file, and where the file is saved. For our example, with a password length of 8 characters and using only 1 and 2, Crunch will generate 256 possible combinations. Our word list file, wordlist.txt, will contain all these combinations and will be approximately 2 KB in size. This small size is due to the limited character set and short password length in our example. In real-world scenarios, where passwords are more complex and longer, the word list file can grow significantly in size, potentially reaching gigabytes or even terabytes. We are now at the final step of our WPA and WPA2 cracking process. In this step, we will use encryption to crack the WPA key using the handshake we captured and the word list we created in the previous steps. This process involves testing each password in the word list against the captured handshake until the correct password is found. Let's dive into the details of this process. To crack the WPA or WPA2 encryption, encryption uses a process that involves creating a pairwise master key for each password in the word list. The PMK is generated using an algorithm called PBKDF2, which combines the password and the SSID of the target AP. This PMK is then compared to the captured handshake. If the PMK matches, the password used to create it is the correct WPA key. If it doesn't match, encryption moves on to the next password in the word list. Before we start cracking, ensure that you have the following files ready. The captured handshake file, in this example, WPA_handshake-01.cap. The word list file, in this example, wordlist.txt. Open your terminal and run the following command, encryption. Here is our captured packets file, WPA_handshake-01.cap. The generated word list file, wordlist.txt. Press Enter to run the command. encryption will start processing the word list and testing each password against the captured handshake. The tool will display the progress in the terminal, showing the current password being tested and the overall progress through the word list. If the correct password is in the word list, encryption will display the WPA key when a match is found. We've now completed the process of cracking the WPA key using aircrack NG and a word list. By capturing the handshake and creating a comprehensive word list, we've demonstrated how aircrack NG systematically tests each password to determine the correct WPA key. Start by finding the IP address of your computer. Open a terminal and run ifconfig lon 0 to locate your IP address. Note down the highlighted part, which is your computer's IP. Next, open a web browser and type 192.168.1.1 in the address bar. This is typically the IP address of your router. If your computer's IP ends in .2, change it to .1 because that's usually the router's IP in the subnet. This will take you to the router settings page. On the router settings page, you'll be prompted to enter a username and password. This information is usually provided by your internet service provider or written on the sticker attached to your router. Enter these credentials to access the settings. Once logged in, it's important to strengthen your router's security settings. If possible, connect to the router using an Ethernet cable to prevent potential deauthentication attacks. Modify settings such as encryption type, preferably WPA2 or WPA3, Wi-Fi password, and other security configurations as recommended by your router's manufacturer. Every router model has different settings, but the process of accessing and modifying them remains similar. Ensure your Wi-Fi network is secure by making these necessary adjustments. But first of all, we will generate a strong Wi-Fi password. Open a new tab in your browser and search for a strong Wi-Fi password generator. One recommended site is Rotten Wi-Fi, or choose any trusted generator. Select a password length of at least 8 characters and include all character types uppercase, lowercase, numbers, and special characters. Click the Generate Password button and copy the generated password. Now that we've generated a strong Wi-Fi password, it's crucial to store it securely. Here's how you can do it. Firstly, open your File Explorer and create a new text file. Name it something memorable, like Wi-Fi_password. Open the file and paste the copied password into it. Be sure to save the file by pressing Ctrl+S. Next, open your web browser and navigate to Google Drive. If you haven't already, sign in to your Google account. Upload the password file Wi-Fi_password.txt, your Google Drive. This ensures your password is securely stored in the cloud, accessible only by you. By saving your Wi-Fi password on Google Drive, you no longer need to memorize it. You can access it securely from any device with an internet connection. This method provides convenience while maintaining security. Now that we've generated a strong password and securely stored it on Google Drive, let's enhance our Wi-Fi security by updating our router settings. Firstly, return to your Wi-Fi router settings page. Navigate to the Wireless tab and locate the security settings. Here, you'll see your current wireless security information, including the SSID, which is the Wi-Fi network name, and network authentication currently set to WPA2. To enhance security, update the network authentication to WPA2. Click on the Authentication drop-down menu and select WPA2. Now, in the password field below, click to display the current password. As you can see, it's recommended to use a strong password, so let's paste the new password we generated earlier into this field. Click to display the password again to confirm it's correct. Finally, click the Apply or Save button to save your changes. Your new Wi-Fi password and security settings are now updated to WPA2, ensuring stronger protection for your network. Firstly, open your terminal and use the Crunch tool to generate a word list containing all possible combinations of 8-character passwords using only lowercase English alphabets. By running this command, Crunch will create a word list that includes all possible 8-character combinations of lowercase letters. After running the command, you can see that the size of the file is approximately 1 terabyte. This huge file size demonstrates the immense number of possible combinations, even with just lowercase letters. Now imagine generating a word list that includes all uppercase and lowercase alphabets, numbers, and special characters. The complexity and size of the word list would increase exponentially. The storage required for such a word list would be impractically large, possibly running into petabytes or even exabytes. The time taken to generate and use this word list would be incredibly long, making it impractical for attackers to use brute force methods. This experiment highlights the strength and security of your new Wi-Fi password. Even if an attacker managed to create a word list with random passwords, the sheer size and complexity would make it extremely difficult and time-consuming to decrypt using tools like aircrack-ng. By understanding these factors, you can see why having a strong, complex password significantly enhances your Wi-Fi security. Your network is now robust and well protected against potential attacks.